Okay, so in the last lesson we learned about the formal definition of a derivative, and it was a huge mess. It looked like that. Okay, and we had to do a lot of algebra to work with this. And this formal definition of a derivative is really important, and it gets us there, but after a while mathematicians got sick of doing this tedious work when they started to realize some patterns. And so the next few lessons are going to be me teaching you the patterns that they recognized. And I'll be showing you the notation for the rule, but primarily you're going to be responsible for using the rule. So on the front, I'm not going to bog you down with too much today. We're going to learn two simple rules. This one's really easy. This one takes a little bit more thought. But the constant rule is the first one we're going to look at. And in mathematics, a constant is a number. So whenever we're talking about the constant, we're talking about a number. So what this is saying is the derivative of this with respect to x is 0. The derivative of any constant is always going to be 0, no matter what. And why did I put a graph here? Well, because I want to show you this graphically. So let's take any constant. Let's say that we have an equation like y equals 3. So what that means is that we have a horizontal line going through the y-axis at y equals 3, right there. So you can tell very clearly by looking at this line that it's flat. The slope is 0. And that's where this rule comes from. If you have an equation that is equal to a constant, then the derivative dy over dx, even though there's no x, is 0. Okay, every single time. And so we can look over here. We've got some examples, and we're not going to graph all of these, but if we have y equals 7, that's a flat line going through the y value 7 on the y-axis. And so we would say dy over dx equals 0. If our constant is 0, our derivative f prime of x is still 0. Notice the different notations. I'm trying to throw those in there. Here we've got s of t equals -3. So even if your constant is negative, the same rule still applies. S prime of t equals 0. Kind of getting the pattern here? And then this here, y equals k pi squared. Well, this is still a constant because k is a variable for constant. So don't get that confused. This is not standing for an actual variable. Typically in mathematics, k is a variable for a constant. So this is kind of like my challenge problem. And so we would write dy over dx is equal to 0. Because after you plug that constant in, you would just have a number. Number times pi squared. Alright, so that's the constant rule. Not so bad. Now let's move on to the power rule.